So, as I said, my name is Bartosz Szulc, but you can call me Bart, and I lost my slides. I'm going to talk about Wiremock, or more general test doubles in the world of microservices. If you are on Twitter, you can follow me. This is my handle, Bart Szulc. If I won't do the presentation in time, and we won't have enough time to go through questions, you can always come here and ask me questions directly. If not, you can always send me an email to my company email. I work for Bartosz. You can also send email to my another company address. Yeah, why not? I hope I will be able to answer your questions. So enough about me. Let's move to the tool. Let's move to microservices. I'm just curious, how many of you work with microservices? Okay, so there are a few people. That's okay, because the agenda will be quite broad. You don't need to work with microservices. You don't even need to work, I think, with distributed systems to get some of the tool and use this tool. I think in your context. What will be the agenda for the presentation? First, I will just describe the context, why we are using doubles in tests, why Wiremock. I will talk about architecture of Wiremock. Then move to capabilities, like basic capabilities, what you can do with Wiremock. Talk a bit about setup, how you usually set up the tool in your tests. And then we will discuss something very important, which is risks. Like what are the risks introduced by test doubling, and what are the risks for Wiremock. And hopefully I will have enough time to go through exploration. So you don't need to have experience in test automation. You don't need to be a cloud QA. You don't need to work with microservices. But this presentation definitely is for you if you are automating and work with microservices. But also if you're an exploratory tester, hopefully when we go to the last stage of the presentation, you will find that the tool might be also useful for you to help you explore web applications even better. Okay, so let's start with the context. Nothing makes sense without it, right? So I'm going to talk about example, show you how to use the tool on example. So this is the real world situation that you may find out yourself in. Let's say that you are a customer and you want to get invoice. So you are sending a request to some to some folk, give me an invoice, right? And this folk is probably talking to accountant to get the total amount of the money you need to pay, to ask that accountant to calculate something. And probably there is also some guy who works in marketing who calculates the discount that you're getting for your order, right? So this is something that you may encounter in real life. When it comes to IT systems, this is reflected in something like this, right? So you have some kind of REST API that allows you to generate invoices. This REST API is handled by some kind of internal service that where the logic for generating invoices lives. And this invoice service, in this case, talks to those two different services that are responsible for calculating total and also for generating or calculating discount. So this is how usually things work in nowadays applications. And you probably also have some kind of specification of what the API is, what is there in the system, what is available. This is a Java system, so you have some classes, some methods, some arguments that are accepted by those methods. So when it comes to testing, and let's say that we want to test that the invoice is properly generated by the invoice service, what we usually want to do is we want to limit our testing to a particular component, right? Particular unit of code. We only are interested in confirming that this unit works and don't really want to test other units that the unit depends on. And this is because we care about speed, we care about accuracy, and we care about reliability of tests. So we don't want to run into this situation, right? When we are testing the invoice service, and together with the invoice service, we are also testing all the dependent services. Unfortunately, in the monolithic systems, so where every part of the system lives in the same code repository, runs in the same process, etc., we have something called Mockito. Who of you ever used Mockito? Okay, so there are a couple of people who use Mockito. I'm going to compare Wiremock to Mockito. So Mockito is your common tool that you will use to mock dependencies. So replace like real implementation with something that mocks that real implementation. But we are no longer in the monolithic world, right? Like we are now in the world of microservices. So we have plenty of distributed microservices, services that live on different machines, run on different processes, where we cannot use Mockito. So what we can do, and let's first look into how would that system look like in the microservices world. So instead of having just an invoice service, you probably would have invoice microservice. So just like an application, a web application exposing yet again a REST API, you would have this invoice service responsible for generating invoices. But this invoice service would no longer talk to some other Java class, would no longer call some Java object, but would rather talk to some other microservice. Like in this case, it's a total microservice, and would communicate over HTTP. Would probably send some REST API call requests, get some data in JSON, etc. And you probably would also have in this kind of system another microservice that would be responsible for generating or calculating discounts, right? And instead of having API specified as on the previous slide as just a collection of classes, collection of methods that accept particular parameters, you would have something like this. This is a thing that you can encounter while working on microservices. This is just a description of what particular microservice allows you to do with it. Like what is the API of that microservice? What is the REST API that it's exposing? And it's in a text format. With it, you can understand that this particular service that is described by this specification is the total service that it exposes some API that's available under REST API to total path that is support GET requests and expects some kind of information. It should be post, but expect some kind of information in the payload and responses with 200 with another type of object if everything goes well, and accepts orders and returns totals, right? So this is kind of specification that you usually see in the world of microservices. Okay, but still, the same principle applies to microservices. If you want to test internal class of particular microservice or particular microservice, you want to test it in isolation. So you want to limit the scope of your test to just this microservice or just this particular class that you are interested in. You don't want this test to test other microservices that are available in your system, because you can run into a situation where, like this example is pretty basic, right? You have three microservices, and there's one microservice that talks to those two remaining microservices. But in the real world, there might be hundreds of different types of microservices, and there might be a hierarchical structure in those microservices. You may have microservice A talking to microservice B talking to microservice C. You may have asynchronous communication going on, and if you made the mistake of testing everything together, your test definitely won't be fast, your test definitely won't be reliable, and you may have a problem with accuracy, like determining where is the root cause of a problem that test spotted. So we still want to limit or isolate our test to particular microservice or to particular class or object in that microservice. And unfortunately, we cannot use Mockito because we are no longer working with single application. We don't no longer work with single JVM. We have distributed services, distributed JVMs, and yeah, Mockito basically won't work for us. But fortunately, we have Wiremock, and this is what this is the tool that I'm going to talk about. And I'm going to compare it, like its capabilities to Wiremock. So if you know Wiremock, it should be pretty easy for you to translate what you know into Wiremock. Yeah. Okay. So that was the short introduction about like the context that we are in. Now a bit about architecture. So what is Wiremock built of? So first of all, this is how you install Wiremock in your test framework or in your code base, right? It's just another library that you will introduce into your Java code base. It's a standalone library, so like you just need to put this thing there to have everything. You don't need to put any other dependencies of that of Wiremock. Everything is in this single jar file. That's why it's called standalone. What's in the jar file? So first of all, you have Wiremock server, and I mean the reason why you have Wiremock server because Wiremock is mocking services, right? Like HTTP services that work on HTTP level. So you need to have some kind of server that your tests will connect to instead of like real servers. This Wiremock server is exposing REST API that you are using to instrument Wiremock. And there are also some internals that are responsible for generating responses for particular requests. And everything runs on Jetty, like embedded Jetty. This is just a web server where Wiremock is deployed, and that Jetty server runs inside the same process as your tests, as your application that is being tested. So that's everything. Everything comes with this standalone package that you introduce as your dependency. There is two more things to that. The first thing is that you have like Wiremock client, so you have classes that allow you to talk to the server, to the Wiremock server, like to start it, to stop it, to clean its state, or to instrument it. And also there are some JUnit rules. So if you know about JUnit, you probably also know about rules. So there are method rules and class rules that you can use to start the Wiremock, stop it, and also clean it between tests. And this is how you usually you would set up Wiremock with JUnit rules in your unit tests. And yeah, so there is this part, right, JUnit rules. And here is how like usual communication between your tests and Wiremock with those JUnit rules would look like. So you would probably have one single class rule that would be responsible for starting Wiremock server once. Doesn't matter how many tests you have in your test class. And then each time you run a test, the mock rule will be responsible for tearing down configuration of Wiremock, cleaning it up, so you don't have any state leaking between tests. And at the end, when all the tests in the class are executed, the Wiremock class rule would get rid of this Wiremock server, would stop it. So that's basically how Wiremock is built. That's basically how the architecture looks like. Now about capabilities. So what you can do with Wiremock. The presentation is about test doubling. So as you probably know, there are three types, like the three major types of test doubles. You have stubs, you have mocks, and you have spies, right? And this is how you create a stub with Mockito. So you basically have this static method called mock. In this case, we want to mock total service, and we are instrumenting that mock to return like some total when a calculate total method is invoked on the mock, right? And this is a stub because we are not really interested into what kind of arguments are passed to the method. That's why we are using this any. We don't care what's the product that is passed. We don't care how much of that product is passed to calculate the total value of for invoice, and we don't care about like some kind of other information that is needed to generate or to calculate total. Yeah, and we can do a similar thing with Wiremock, and this is how you do that. Like we are no longer mocking calls to methods in Java. Instead, we are mocking calls to HTTP for HTTP requests. So you need to specify what is the method, HTTP method that you want to mock, and also what is the path that you want Wiremock to respond with a specific response, right? So in this case, we want Wiremock to return some JSON, like this total object, whenever from tests we call REST API total, and that call is a post to that path. And as you can see, like similarly to the previous slide, this is yet another stub because we are not looking into what kind of values we pass to this REST API total with this REST API total request. Like we are not looking into is the product correct that we are putting into payload, is the quantity correct? We just want to, no matter what is put into the payload, we always want Wiremock to return specific value. But you can also mock with Wiremock, as you used to do with Mockito. So the difference between stub and mock is that mock also tests the values that you pass to a method that you want to double. So in this case, we are using Mockito, and yet again we want Mockito to return specific value when the calculate total method is called. But because we are mocking now, we are interested in confirming that this method is called with a specific type of product, specific quantity, and specific value of discount. So this is the big difference between mocking and stubbing. And we can also do that with Wiremock. Same as in previous slides, we use this stub4 static method. We specify HTTP method and a path that Wiremock needs to double. But this time we also specifying what's in the request, like what's the body, what it should contain. And if for some reason the body is not as it's specified here, Wiremock will not respond with this what we put in the return method, right? So this is the big difference between stubbing and mocking. Okay, one thing worth keeping in mind while working with Wiremock is that by default Wiremock will return 404. So if for some reason you programmed Wiremock to return some kind of total when the product is named scissors, but when you are running your tests, what really happens underneath is total calculated for product called, I don't know, bike. Wiremock will not throw any kind of exception, will just return 404. And maybe you will be able to catch that in your test, maybe not, but it's worth keeping in mind. You need to be aware that Wiremock will not throw exception if you are calling it with something that it wasn't programmed to handle. There is a way to avoid such situation, and you basically need to override the default configuration of Wiremock, and you need to say to it that whenever I'm calling you with something that you weren't programmed to handle, throw an exception. And immediately, if that situation ever happens, your test will fail. Okay, one more test double that you may run into is SPY. So SPY is about like checking side effects. So let's say that when we are generating invoice, an event is generated that is published somewhere to some kind of event queue. And this is like some kind of analytical event, right? So you can check with Mockito how would that, and confirm that that event would be, was pushed to event bus. And this is an example how would you do that. But if you are working with microservices, that event probably would be sent to some kind of analytical microservice or something like that. Fortunately, Wiremock also has capability of spying, so it can analyze what kind of requests were sent to some kind of HTTP resources, and you can verify how often, how many times it happened during a test, and you can also verify what was the payload that was sent while you were executing a test. There are more capabilities that I'm not going to go through because just I don't have that much time, but I will also tackle them later. Okay, so now a bit about setup. So how you set up Wiremock in your tests. So this is what you have, right? So you have Wiremock running on Jetty, you have some kind of client, and you have those JUnit rules that you can use to start up the server and also communicate with the server. And you have your unit tests. So the first thing that you will need to do after starting the Wiremock server with JUnit rules, you will probably want to program Wiremock. So you are basically stating what kind of requests Wiremock should handle and how it should handle those requests, like what kind of responses it should generate. Once the program is done, you move to initializing the objects or the classes that you want to test, right? So you know that you want to test invoice service. You know that invoice service probably will communicate with some microservices. So you want to say to that invoice service, instead of communicating to real microservices, communicate to those microservices that you have on localhost and basically will be handled by Wiremock. And once you run your test, first you will call some method in your invoice service, and invoice service will later call to the microservices which are represented or doubled in your test with Wiremock. Okay, but that's how it works for unit tests. What about some integration tests, let's say? So let's say that we have an invoice service or invoice microservice running, and we also have a total service, and we also have all the other services that the invoice service depends on. And now we want to run a test from another JVM that will go through the end-to-end experience, like would send HTTP request that will be handled by REST API of the invoice service, and that HTTP request would be later passed to total service and to the discount service, everything to return some kind of invoice back to the test. So still, you need to first initialize your environment, initialize the system. Probably you need to configure it that the invoice service doesn't talk to some kind of staging microservices like staging total service or staging discount service, but instead invoice microservice talks to some services on localhost. Then you need to program the total service, which is replaced by Wiremock, and then you can talk to the invoice service from your tests as you would normally do. You also can use a capability available in Wiremock that allows you to transform and create responses in runtime, and this is something called transformations. So maybe you work with microservices that generate authentication tokens, like in this case it's JWT authentication tokens, and you want this and you want Wiremock to always generate valid request tokens every time it's called. So for that purpose you can use transformations, and this is like an example how you can implement a transformation. Before Wiremock sends a response to your request, you can manipulate that request that response a bit. You can add to that response some missing headers, some missing fields, and this is a great way to remove the code responsible for generating JWT or any access tokens from your tests and move it to Wiremock itself. So this is the setup that you will probably end up with your integration tests. Of course, you probably would run your microservices on some kind of Docker containers, so you can run them locally with ease. And probably like the configuration would be managed by, for instance, also by Docker, right? I forgot how it's called. Anyone can remember me how the tool is called? Yeah, Compose. So, yeah. So you probably would use Docker Compose to create like the complete test environment that has like those two microservices when one microservice is really Wiremock properly programmed. Okay, so we have our setup. Is it are we done, right? Like, is everything, or should we feel done? I don't think so. There is a great risk when we decide to mock. And the risk is there because we are not really talking to real implementation, like real services in our tests. What we are talking to is like some kind of some kind of doubles, right? Like how much you can trust your tests where you use doubles depends on how good your doubles are, how good your mocks and stubs are. And I heard that once you mock something, it's the point of time when that mock goes completely obsolete. So you need to be aware of that. So once you introduce a mock to your test, you are making a snapshot of the thing that you are mocking, and you need to put some kind of controls in place that will continuously check that this mock is what's really happening on production, that the service, that microservice that you mocked with Wiremock works the same way as the real service in production. And there are ways to assure that. So let's first look into something that you could use, you could see while working with unit test and Mockito. So this is an example of Mockito implementing logic. So we want the thing that is mocked with Mockito to behave certain way, depending on what is the argument passed to a method. And when the argument is over 1,000, then the mock should raise an exception, like throw an exception. And the reason why we implemented mock that way is because when we implemented test, this is how the class behaved. But at some point of time, someone may change the class that you are mocking, right? And the exception may be not thrown, or may be thrown on 900 or 999. So now you need to put in place some controls that will make sure that the exception is thrown, and it's thrown when 1,000 is passed together with call of a method. And how you are doing that, like how you are assuring that your mock replicate what's real and what's really happening on production, is you are setting up contracts. And I know that you probably know about contracts because you heard about Pact, because you heard about microservices, but it isn't really a new concept. We used to have, and we still have, contracts for unit tests, for instance, just to avoid the situation when you have some mock that isn't replicating what's really happening in your code, like does not replicate production code. And this is an example how you would implement contracts in unit tests. So you're basically implementing 2 unit tests. First, to confirm that the real implementation of what you are mocking in the previous test is throwing exception when the value is over 1,000. And you have another test that is like happy path test that just confirms that if you are calling a method with 999 or something below 1,000, then some value is returned. The problem is that in the world of microservices, it's really hard to establish such contracts because you have teams working in multiple locations. The first thing is that you have multiple teams. They may work in multiple locations. They may work even on multiple different code bases. Some may work in Java, some may work in Go, some may work in Python. So you cannot really implement just unit tests. You need to have some kind of other types of contracts. And what we are doing is that is this thing, like we have consumers and we have providers. So provider is the party that provides some kind of capabilities over REST API, right? So we have microservices that provide some kind of REST API. And we have consumers, other microservices that consume those capabilities. And in the middle, we have broker. So a party that is responsible for handling communication between those two. So this is the usual conversation that is happening. A consumer comes to the broker and says, I need a thing. And basically specifies what they need with some kind of like easy to understand specification. This is Pact. If it's the first time you heard about Pact, I'm not going going to describe that into details, but this is basically a way of representing communication between two parties on HTTP level. So I want to call some kind of resource, I want to call it with some kind of HTTP method, and I expect this resource to be under certain path. When I send some kind of body with specific structure, I expect you as a provider to return headers, return some kind of object in the payload, and also some kind of status code. And we are able to write down this documentation in this kind of format that is understood by not only humans but also by libraries, by programming languages. Okay, so now you can think that, okay, we need packed, right? But we already are using Wiremock. So what's now? Not only we need to program the services that we are mocking in our tests with Wiremock, but we also need to create like this packed specification of what the communication looks like. So we have a description of the communication in two places, in our tests and also in packed. Fortunately, there is a library that you can use. It's open source, with which you can generate packed files. So if assuming that you already have tests that use Wiremock to mock microservices, you just need to first like declare the dependency, and later whenever you are working with Wiremock, just call Wiremock with this method, and whenever Wiremock is handling some communication, is returning some kind of responses in your test, it will also generate packed files for the communication that he handled. Okay, so yeah, this is the usual setup for integration tests, and if you use that library, you will also have a set of packed files generated in runtime for you. Okay, so consumer knows what they expect. They are passing that information to broker, right, as packed files. And provider confirms that, yeah, this is what we are capable of giving you. This is what we are for. And basically, like this is the documentation that is available from the consumer, from the provider side. So this is Swagger, just explanation of what's the provider REST API. Okay, and also broker is responsible for not only storing those packed files, but also storing the Swagger files. Okay, and whenever a provider wants to change something in their API, in the REST API, they need to confirm that they are not breaking any communication or expectations that were written as packed files. Right? And also whenever a consumer wants to request something new or expect something new, they need to confirm that that thing is available. Okay, there is one problem with such approach, and it's about pipelines. So let's say that you have a provider pipeline, right? So if you have some kind of experience with packed, the idea is that because you know what is expected from you as a provider, you can run tests against your service that will confirm that all the expectations are met. The problem with that is that once you start doing that, you are making yourself dependent on those other services, those consumers of your service. And you may run into bad tests that run a long time. You may have duplication because there are multiple consumers that want you to serve the same thing, but they are not talking to each other, and you need to run multiple same tests in your pipeline. So it's a bad thing. And the same problem is hurting consumer. So if you want to request for something new, you need to first confirm that that new thing is available in the provider, on the provider side. And one thing of doing that is just like installing the provider microservice, starting it up, running your client code against that microservice, and confirming that the thing that you want another service to provide is really available. But we were talking about Swagger, right? So where is the Swagger? Like where did Swagger got lost? Like there was nothing about Swagger in the pipelines. Like there was something about Pact, but nothing about Swagger. So this is what provider gives you, right? Like this is the API that it provides, and it's Swagger. And consumer knows what kind of communication they want from a provider to handle. So those two are textual representation of the communication that is happening between provider and consumer. So why not just simply overlay those two files and see if they are like if they click, right? Maybe there are some differences. For instance, I'm expecting as a consumer some resource under a certain path, and by analyzing Swagger, this path is not even exposed in the provider API. Unfortunately, there is also a tool that you can use. It's also open source, which basically validates Swagger against Pact and Pact against Swagger. So you don't need to run your tests or consumer or provider's tests in your pipeline. You just need to confirm that the new version of your API is still handling contracts in Pact of all your consumers. And the other way around, whenever you are changing your communication with provider and generating new pacts, you need to confirm that those pacts are in fact handled by providers by checking them against provider Swagger. Yeah, so we are running in good consumer and provider pipeline. So yeah, we got rid of this inherited risk of test doubling. So yeah, Wiremock definitely is for mocking in the world of microservices. And I wanted to talk about exploration. Unfortunately, I don't have time for that. But the slides will be available to public. There is a video. There is also an information of the capabilities that you can use while exploring software. And yeah, I can only say that Wiremock can be used for exploration as well. And most of the times I use Wiremock for exploration. Okay, so thank you.